So hello again. Thank you for joining us today, where we will introduce you to memoQ AGT, which stands for memoQ Adaptive Generative Translation. Before we start the presentation, let me do a quick housekeeping rules. The webinar itself will be recorded and it will be available on our site. You will receive an email when it's there, and also you all who are here will get the Q&A sheet as well. The presentation itself will be around 30 minutes and maybe it can go up to 45 minutes, but hopefully it will be a short presentation just to show you what memoQ AGT is, and then we will have a 10-15 minutes time for answer all of your questions that might come up. Our presenter today is Gábor Ugray, who is the Senior Technological Advisor here at memoQ. Gábor, welcome, and let me hand over the mic to you.
Thank you very much for the intro, Benza. So really quick intro. I'm Gábor Ugray. I'm memoQ's technical co-founder. So I've been around since the very early years, since around 2005. In recent years, my position, I've been contributing as a senior technology advisor. And most recently, I've been looking at memoQ's approach to using generative AI to enhance our offering and to create more value for our customers. Let me take over the screen sharing and show my own slides. I sort of to segue from my introduction, I thought I would say a few words about my previous job, which was the only job that I had before memoQ, which had to do with machine translation. And that's where I also met my co-founders at the time, and we were working on actually a rules-based machine translation system. And the very idea that made us start memoQ was, I'm not sure disillusionment is the right word, but something like that with the very research-centric work that we were doing previously. We realized we just want to do a much more down-to-earth, very simple piece of software that solves very practical real-life problems for a particular audience, translators, translation companies, organizations that need to manage translation. And we kind of vowed almost to not make it, not make this software too smart, just make it just right for a particular purpose. And it's very interesting because now with AGT, we have kind of come full circle, and memoQ does end up incorporating some very cutting edge artificial intelligence magic. So I'm going to start hopefully if I can advance my slides by talking a little bit about nothing else but machine translation. So don't worry, I'm not going to give you an extremely deep history lesson here, but let's just take a quick look at how we got to the point where we are right now when we are talking about generative AI and AGT. Oh, by the way, just a final footnote about the housekeeping bits. So we are taking questions, but I am not looking at the chat as I'm presenting. So what will happen is at the very end, hopefully I will finish in under 45 minutes, we will have ample time to answer questions. So just please use the chat, use the Q&A. Benza will read those out, but I'm not looking at questions as I'm presenting. All right, parenthesis over. So machine translation does go back a long way. There were multiple paradigms, there were multiple ups and downs, there were various phases of the hype cycle. I think what we kind of most remember is SMT, statistical machine translation, which was the last paradigm before the current one, which was interesting because it was somehow more predictable than what is happening now, but almost everything that it produced was word salad. Almost none of it was grammatical sentences. And really the breakthrough came around 2015, 16, 17 with neural machine translation, which was the first approach that really produced human-sounding fluid sentences. And this is what we are seeing in generic services like Google MT now. There are two funny little abbreviations there at the bottom right, recurring neural networks, and LSTM, which is long short-term memory, really obscure words. These are the structures of the model, and there is actually one that's missing here, which ended up being the dominating paradigm for Neural MT, and that is transformers. It's a kind of architecture of these networks. All right. I want to talk a little bit about Neural MT, Neural Machine Translation in particular. It is a model. It's not an algorithm. It is trained on a large amount of data. Essentially, what you need is a large pair of known translations. So this is what I illustrate here. I like dogs, and you expect the translation "Ich mag Hunde." You kind of feed it to the network at the very beginning. It will come out with some gibberish in the very first iteration. Loss is a function that calculates like how far off am I the expected translation. That generates an error, and that gets propagated back through every layer, every little component of the network. This is a very long and tedious process. It is also very computationally intensive. You need, at the very, very minimum, a couple dozen thousand segments to segment pairs to train a model that will work in a very narrow domain. But, the large generic machine translation engines like Google Translate, Microsoft Translate, those really have been trained, I think, at least on dozens of millions of sentence pairs. This is called supervised learning because you need to have data where you have a ground truth. You need to have labeled data, meaning you have known translations for every source segment. And this is a bit of an obstacle because there is only so much sentence aligned translated data available out there in the world. And then once you have a trained model, then you no longer change the model at all, but basically you just feed it something new, like the dog ate the SD card, and then it will make a prediction, which is it's really more like a statistical prediction that says, given this input, a likely translation might be "Der Hund hat die SD-Karte gefressen" or something like that. The important bit is this is still computationally intensive, but much, much, much less expensive than training the model. So training the model is hard once you have a trained model, and it's an order of magnitude less computationally intensive to use it to translate. And then I want to put machine translation as it is used in the localization industry a little bit into context. And not the particular image, but this illustration, the idea comes from the second most well-liked presentation ever in the history of memoQ Fest. This was Mike Dillinger in 2017. And he used this image to show, like, this is what I think he was talking about, the lab context, but also in the public imagination. A machine translation, a translating machine is this little autonomous robot. You feed it electricity, you feed it sentences, text in one language, and then it kind of goes ver, and you get translation out, and that's all there is to the story. Whereas in reality, the whole story around machine translation, as it is used in production, is a lot more complex. So there's a lot of machinery all around it. There is all the issue of training these machine translation engines. Very often, the really good results don't come from the generic engines. They come when you train an engine with a domain-specific data. So customization is also called domain adaptation. You want to create models that don't just translate anything. Maybe they translate, they're really good at translating instructions for use for the kind of medical device that you are manufacturing. Then the whole process, you very rarely use, you don't typically use, or I think not at all, entirely unsupervised machine translation. There's always a human there reviewing or post-editing in the loop. You need to build a processes around that. Then you need to curate the data to customize the MT. And particularly here's data hygiene. As you are going to do loops, what you want to do is to keep improving your model as new translations come in. But you have to be really careful because you don't want to feed the unrevised machine-generated output back into the training corpus of your engine, because then you're just going to have quality that falls off a cliff. When you make a change, you need to have a way to evaluate quality. You need to have methodology for that. You need to have the tooling for that. And also, at this point, I think it's important to mention, like, some of the really exciting use cases of machine translation do not really come from the translation industry. I think it's fair to say many of these use cases come from the retail industry. Think of companies like Airbnb or even Amazon, which have dedicated machine translation teams, maybe even homegrown machine translation systems. And what they do is, if you're Airbnb, you want to have a system that automatically translates the descriptions of all the properties. So people visiting the site in different languages can also access it, and you cannot expect the owners of the properties to do that translation into 20 languages. So what it does for Airbnb is it generates more transactions, good for all the participants in the marketplace and good for Airbnb. They also have like a very different metric of what is good MT. What is good MT is what makes, you know, more trips happen, more rentals happen. It has nothing to do with our, you know, linguistic quality-based metrics in the localization industry. So I just wanted to essentially highlight that there's a lot of complicated machinery going on involved with MT. But now let me take a different tack and talk a little bit about large language models, which are at the center of text-based generative AI. So large language models, or LLMs, what are those? They are kind of like machine translation engines, but they are not meant specifically to translate. There is one very well-known example. This is when this technology has become sort of like a household name, and that is ChatGPT. ChatGPT is nothing else but a large language model. How do these models work? Don't worry about the specific details on this screenshot. What I want to say here is that it's a really interesting trajectory of evolution, of development. The large language models really are a direct descendant of the neural machine translation technologies that we are using. So this little chart on the left is the topology, is the structure of the various parts of the neural network that make up a neural machine translator. The important bit is on the left, you have something that is called an encoder. And, you know, in very broad terms, that is essentially responsible for processing the input in the source language. And on the right-hand side, you have a part, slightly more layers, more complicated, which is the decoder, which is responsible for, very broadly speaking, generating the translation in the target language. And this model is called the transformer. And what large language models essentially do is they just break it out, the part on the left. They break it out, the encoder, and it's just one half of this model. It's just the decoder. And they are taught somewhat differently from neural machine translation engines. Remember, the neural engines, you had like a source sentence and its translation. So the model was taught to basically predict what the translation of a sentence can be. What a large language model does is insanely simple. Really, this is at the heart of all this magical technology. You give it a context, which is a sequence of words. Well, they talk about tokens, but word is a good enough idea to talk about here. So like, grab some text, grab up to n words in the text flow, and you train the model to predict what the next word can be. And then you kind of move your window a little. Pick, you know, a different window of words, and you train the model to predict what the next word can be. It's as simple as that. It's just, this is why it's a language model. It models, you know, the sequences of words that can make up text or content in a given language. And it is that simple. That's all that there is to it. There's one advantage to this. This is what is called unsupervised learning, because you don't need the labeled training data. You don't need to have source sentences and their translations as ground truth. You can just hoover up any amount of text you can from libraries, from the internet, from, you know, these people get really creative with their sourcing, and you just need text. You don't need to label anything. You don't need translations. You just need raw text. So this is what an LLM is. And this is my little Marxist slide. There is one very interesting thing that happened in the last couple of years. So all of this trajectory started around 2018 with GPT-1, I think it's fair to say. These models really started to grow insanely fast. So the size of the model, the number of parameters in it, decreased by about 100-fold from GPT-1 to GPT-2. And it increased yet another 100-fold from GPT-2 to GPT-3. And we don't really know the size of GPT-4. They have been less transparent about it, but it's just an insane rate of growth every 2 years. And also the amount of text that these systems were trained on grew at similar rates. Like with GPT 3.5, I think the number of parameters in there is really staggering. It's 175 billion. It's essentially the model is 175 billion numbers. And at one point, along this insane growth curve, something interesting happened. And that is this emerging property of zero-shot learning. Like, remember, these models are only trained to predict the next word. You give it a prompt and it continues how it can go on. But at one point, they kind of acquired capabilities to do things they were not explicitly trained for. You can give them a prompt that says, here is a text, summarize it, and then you have a much shorter summary of the text. Or here is a piece of text, rewrite it in the informal register, and then it will do that. And like a long range of texts. Previously, you had to train separate models for that particular task. And LLM is just like a generic language model, but it can still do tasks that it was never trained to do. And then there's another aspect which kind of got discovered along the way, which we call few-shot learning or in-context learning, is that if you don't just give it an instruction, but you just give a couple of examples, and you know what I want you to do looks kind of like this. If the input is this, then make the output like this. Then from these examples, they kind of learn on the fly without retraining the model, and they have even more better output. The context, it's a bit of a technical term here, but remember on this slide, you know, the thing that is being continued, that is what we call context. And then the following sequence of words is always the continuation. So this is where in-context learning comes from. All right, what else is happening? This is kind of like to just, you know, give you a context of the times we live in which all of this is happening. This is like a really neat exponential growth of the computing power of these graphical processing units. These are kind of customer, like end customer GPUs. These are the kinds that you also find in gaming laptops. They have counterparts for data centers that are worse at generating images, but somewhat better at mathematical calculations. So these are not necessarily the ones you will find running behind LLMs, but they're very, very similar. And the sheer growth in computational power applies just the same as we see here. And LLMs really had their breakthrough when ChatGPT was released to the public about a year ago. I think it was November 2022. Already by the time we got there was also a lot of other research happening, a lot of other systems being built and models created, which were maybe less present in the public discourse. But I wanted to show you just this tree, and this kind of represents what happened in the half year between the release of ChatGPT, so that is GPT 3.5, and May 2023, and that's half a year ago. And this graph has really just even exploded even farther since then. It's an interesting thing, just really briefly, like there were a couple of experiments like Naural MT, which were not the decoder part of the transformer on the right-hand side, but the encoder on the left-hand side. There were a couple of encoder-decoder models, but these really are not what turned out to be the real hot commodity. That turned out to be GPT and all the related ones. I think here you can already see Llama somewhere, the thing that just, you know, had a second version this summer. So there's just an insane amount of development going on here, by which I mean to say already at this point, generative AI can produce a pretty impressive level of quality, but there is so much work happening here that we can expect this growth, I can say explosion in quality to continue for, you know, a significant amount of time. And what are some ways to use, what are some of the good ways to use large language models? And this is where this is one example. This is about information retrieval. I think there is a really bad way to use large language models. And a really bad way to use large language models is to go to ChatGPT and ask factual questions. It'll kind of get it right sometimes. I would say it's pretty surprising how often it gets it right, but there's no guarantee. They have no relationship to facts. They have no knowledge of the world. Remember, these are systems that were trained to predict the next word. The really good way, the really sensible way to use an LLM is to give it tasks to make it do something. And the way they are used in information retrieval, and there are systems built around this, like LangChain, you might have heard that name, is to, let's say, you have a knowledge base, and maybe it's a private knowledge base. Maybe it's your company's in-house private knowledge base that is absolutely not even supposed to be shared with the public. So ChatGPT will definitely never have been trained on it. But you want to build a system where you can, you know, ask queries and you can get responses based on this private knowledge base. The way to approach that is to, and this is really what language technology is about, this is really brutal sometimes. You just chunk it up, like really no sensible boundaries. You just chunk it up into 300 character units or something. And there's a particular way of indexing these, which is called based on word embeddings. And this kind of index is called a vector store. The point is you just store these little chunks in a kind of database. And when a query comes in, you calculate the embedding of the query also, and you can just find the chunks that are semantically most similar. And this is a very powerful semantic search approach. It doesn't need to share any characters. It can be synonyms, not even the same words, but, you know, relevant chunks will be retrieved. And then you just assemble a prompt and you say, hey, LLM, answer the following question. And oh, by the way, we have this related information available. Answer the question based on these snippets of text. And then what the LLM actually does is to generate the response. And this, you actually see this happening in Google search results. So when you have these snippets where Google like answers things for you, that is the LLM doing this. And the basis of the information on which it gets answered, those are essentially search results, increasingly bad search results, unfortunately, that are retrieved in the background. And now I have given you all the context, no pun intended. So let's talk a little bit about what adaptive generative translation in memoQ does. And I just go right back to the previous question. It uses a large language model. It uses a generative AI to synthesize, to generate translations based on information that is available in your TMS. So when you translate a particular source sentence, memoQ will do a very conventional lookup in its translation memories, its term bases, its LiveDocs corpora, and with the exact same lookup mechanisms that exist in memoQ, it retrieves translation results. It retrieves fuzzy matches. If you have an exact match, you don't really need the MT, but it will receive fuzzy matches, maybe even very low fuzzy matches that contain a part of the content that is relevant for your sentence. It will also retrieve terminology matches, and then it will basically instruct a large language model to say, based on this information, which is relevant for the translation of the sentence at hand, please translate the current sentence. And this builds on the ability of large language models, which is another interesting emergent property that they acquired. You know, out of the box, they are able to translate. I would say they are, as far as machine translation systems go, they are pretty neat, mediocre translators. They're kind of comparable to, you know, the better generic models out there, but they're not really as good. And they absolutely cannot compete with customized domain adapted models. However, if you don't use them as zero-shot learners, but if you rely on their in-context learning ability, which is exactly what we are seeing here, they become really good translators. So specifically AGT, the system that we have built, let's take a look at what parts it is made up of and how does it work. You need a memoQ desktop client for it. So for now, the place where this service is available from is the memoQ desktop tool. And it talks to an online service, which is AGT that we have built. It is available at agt.memoq.com, excuse me. And that is the place where the actual magic happens. So when you translate a sentence, memoQ performs this lookup, gathers all the relevant matches from the project's TMs, term bases, LiveDocs, corpora, puts together a request, goes to the service agt@memoq.com, which kind of chews on that request, creates a way to address a large language model. The large language model generates the translation, and this is sent back to the memoQ client. Currently, this large language model is GPT 3.5 Turbo in Azure OpenAI. That is the same model that is behind ChatGPT. This is the counterpart that gives higher confidentiality and privacy guarantees. We know exactly in which data centers this data is. It's all inside the EU, and Azure offers guarantees that none of this information goes back into further training the system or leaked to other customers. And what is the benefit of all this? Let me go back to this picture so that we are reminded of all the things that are going on around machine translation. Essentially, this makes life a lot simpler compared to achieving the same goals with Naural MT. With Naural MT, if you wanted to customize your translations, you need to retrain the entire model with new data, and you generally need a fair amount of new data. So you need to wait until a couple of thousand segments of newly translated content accumulates, and then you can throw that new training data at the model, create a new iteration of the model. This is an offline process. None of that is necessary with AGT because the adaptation happens on the fly through in-context learning. The actual model, the large language model, is not retrained in the process. And this happens directly integrated into memoQ. So all of the difficulty of like, what is the data that needs to go in there? How do I make sure that unreviewed translations do not go back into the data that will be used for the next translation? This is what I mean by data hygiene. This is what a TMS is for. This is what memoQ does for you. This is where you have project TMs. This is where you have working TMs, reference TMs. This is why you have the workflows of review, translation and review steps, and storing translations in the right place. And the really cool thing by this is a very, very good match, a match made in heaven for memoQ, is that memoQ is a TMS or a CAD tool that already has a lot of advanced leverage features. And that is what I want to show on the next slide. So this, from memoQ's perspective, AGT is not really disruptive. It's yet another incremental change on top of the long history of advanced leverage functionality that memoQ has. So what are some of those? I will actually be able to highlight some of those when I do my hands-on demo. From very early on, we had fragment assembly. So you have a sentence where parts are there. memoQ will just replace those parts. And it will give you a not grammatical sentence, but maybe, you need to spend less time editing that. This is essentially example-based machine translation, by the way. memoQ has automatic concordance. So if it realizes, oh, hey, your current sentence has a couple of words that occur as a part of a lot of other sentences in the translation memory, and then it highlights that for you. These are the yellow matches. And this is essentially telling you, maybe it's worth doing a concordance search for this because this seems to be recurring in your TM a lot. We have live align that allows you to align two documents on the fly and immediately start getting matches without first fixing up everything. We have translating concordance, which will give you the probable translation of the text that you are searching for right in the concordance window. We have match patch, which fixes up fuzzy matches based on terminology matches that we have there, which is also another form of example-based machine translation. We recently built a new translation memory engine, which we call TM+, which is has equivalent functionality to the TM that memoQ always had, but it can more robustly and reliably handle really, really large amounts of data. And recently we started integrating AI QE, which is related to machine translation, which is an automatic method of predicting the quality of individual machine translations. So you know which parts need more review and which part you can have more confidence in. And memoQ AGT essentially fits in this tradition of advanced leverage in memoQ. Enough talking now. Let me do a little hands-on demo of AGT in memoQ. So for that, I'm switching to my Windows machine here. I think I need to make this thing at the top of my screen go away. It will not go away. That's interesting. Anyway, so what we see here is the website, the landing page of agtmemoq.com. Many of you have already signed up for the waitlist, so you will have seen it. And what we see here is a memoQ project. So I already prepared this project for you. There's a document sitting in here. This is actually a subset of the strings from memoQ's own help files. So it's memoQ documentation. And I have a translation memory of memoQ's user interface strings. Plus, I have a term base, which is general memoQ terminology. And if I take a look inside the document, you can see that these are, in fact, sentences from memoQ's help. And I get a fair number of matches for almost all or most of these sentences. So I have high fuzzies, near exact matches, but sometimes I have lower fuzzies. In order to use AGT, it is hidden, kind of disguised as yet another machine translation plugin, but it's a kind of peculiar machine translation plugin. So let me create a new MT settings resource for this. AGT settings webinar. And in the settings, these are all the plugins supported by memoQ right there at the top, which is a pure alphabetical coincidence. Maybe, maybe not, is Adaptive Generative Translation. I need to configure it, which is essentially just putting in an API key so that the plugin in memoQ can authenticate itself against the AGT service, and then the service knows that this is that particular user. How does that work? Let me switch back to the browser window. So if you click Access AGT, then you need to log in with the memoQ account. I already have the login stored here. And this is what your, there's not a whole lot of user interface here. Essentially, you can keep track of how many characters you have used already and how much you still have in your quota. And let's create a new API key. API key for webinar. And this is the key that you need to copy and enter in memoQ. Click verify, key is correct. And now AGT is unlocked in memoQ. So it can talk, memoQ can now talk to the AGT service. It looks very much like pre-translation. It's a different form of pre-translation, if you will. So it's in the preparation menu under pre-translate. Previously, this used to be a single command, and now we have translate with AGT here as well. Let me really quickly kick off a process just to show you what's happening. And then I will cancel it because I have a lot of segments here. It essentially inserted all of these matches as machine translation results. And if I go back to my, well, of course, I will not see the numbers update here, but this has eaten a little bit into my quota here. Let's take a closer look at the specific options that AGT has. Here's another way to find the same command. It's also there in the context menu. The part at the top is very usual memoQ fair. You can select the content that you want to work on, so the scope of the operation. Then this can be part of a workflow where you first pre-translate it using exact and fuzzy matches from translation memories and corpora. So those might already be sitting in your document. And most likely you don't want to overwrite segments for which you have a very good or good enough TM match. So this is a little limit. This says, if I have a segment that is pre-translated, but the match rate is below 90%, then I don't want to keep the 90% match. I want to go to AGT and use the machine translation from AGT instead. The part at the bottom configures what kind of information AGT will use for translating every specific sentence. You can set a minimum match rate, which is a lookup match rate, to retrieve results from translation memories and corpora. Like, remember, the point of AGT is that it puts all these existing matches from memoQ, including TM matches, into the prompt. For that, you need to do a lookup. This configures how low you want to go with the fuzzy lookup. There's an upper limit which says, after a while, just throwing more information at the system will yield diminishing returns, plus it also costs more. So you can set a limit. For any particular segment, I don't want to include more than 6 TM and 6 turn-based matches. And finally, at the bottom, this is normally on, you can say, oh, if I don't have at least one match, or if I don't have at least 2 matches, I don't even want to go to AGT. Maybe I will be better off using a classical MT service for those. Okay, so these are the settings of AGT. And now let me just clear everything that I have inserted here and show you the effect of domain adaptation, or this customization on a particular segment. So I have a segment here, and I'm going to send this to AGT first without any of these matches here. So let me remove my TM. Yes, I don't want the TM. Let me remove the term base. So now I have 0 matches. And this is not what I would normally want to do, but for the sake of demonstration, I'm just going to send this particular segment to AGT. And this is the translation that it comes up with. I'm just going to copy this to the next segment so we can take a look at it later. And now let me start again. But now, let me include the terminology, and let me include the user interface strings again in the project. And let's do a translation operation again. And what you see, because the request came accompanied by all this extra information, the translation has changed, and this is not predictable. So don't think any of this will be deterministic. But right now, this is like a really good example, because login to server as a thing, it's already in the translation memory. So it was translated in the user interface in a specific way, anmelden, and in that knowledge, AGT came up with a translation for the segment at hand, where it didn't use Auden server einloggen, which would also probably be a potentially good translation, but it used the preferred translation for this particular data set. And that is it. Let me go back to my slides, and I just want to give you one last bit of information about the way we are launching AGT. So agt.memoq.com is where you can access this. There is a web page there, so that is the landing page. You can click on the sign up button, but for now we have a wait list, and we will be gradually letting people in from the waitlist to join the service. We also want to be cautious when we are releasing this. We don't know how much load to anticipate, so we will be letting people in from the waitlist cautiously. This is a service that is accessible with a memoQ account. You saw that happen as I logged in. That was my memoQ account, the same one that I would use in my.memoq.com to take a look at my licenses, to take a look at my SMA, etc., etc. You saw that AGT keeps track of usage, and there is a quota. It will have a volume-based pricing. Currently, we do not have the final details of the pricing. So right after release, as we are letting people in this beta period from the waitlist, we will be giving away free quotas individually. And to access the service, you need memoQ desktop. So you see that I used Translate with AGT. That functionality currently is available in the memoQ desktop tool. It is available both in Translator Pro and Project Manager. You can check out an online project, and you can use this function in the checked out copy of an online project as well. But for the time being, this is not available in the PM interface of online projects per se. And at this stage, AGT supports 21 languages. Some of these, like English and Spanish, have like a lot of variants. So, you know, if you include those, this is a lot more. But essentially, this is 21 languages. And this is a somewhat arbitrary cutoff point. We took a look at the amount of training data in the training corpus of GPT 3.5. And made a cutoff point. So languages get increasingly less coverage, and we decided we will go in the first phase with these 21. And that is it. I very professionally kept to the 45-minute mark. I'm almost surprised at myself. Thank you for watching. Thank you for joining. And now this is time to answer some questions. And here I summon Bence's help to read those out for me.
Yes, thank you, Gábor, for the presentation. It was a really good one, and I really like the illustrations and stuff like that. We had a lot of questions. Actually, we have 21 questions now. So
that's exactly the number of languages. Is that a coincidence?
I can say it is or it is not. So let me just begin with a quick one. You said that agt.memoq.com is hosted in the EU. Can you be more specific about that?
So there are different things here. agt.memoq.com itself is hosted in a data center in Frankfurt. The large language model that is working behind, so as part of the AGT service, so which creates the translations, that is also in an Azure data center in the EU. Currently, the one that the live system uses is in Sweden. We might, as we expand, also have instances in other data centers, but we will probably for the first time stay in the EU. The terms that belong with that are detailed in the terms of service that specifically relate to AGT.
Thank you. The second one is, can personal data be sent through the machine? I know you said it's GDPR compliant, but DeepL, for example, still has is their privacy statement that you should not send personal data to the system, even with DeepL Pro subscription.
I think this is always like an individual deliberation based on the situation that you are in. We can give the exact same confidentiality guarantees that the service that we rely on gives, which at this point is Azure OpenAI. I am not a legal expert, so don't take my advice from this. Please take a good look at the terms of service and make an informed decision. We are definitely not using this, and Azure definitely also is not using this. This data is not recorded, etc., but it does leave your computer. So, you know, your mileage may vary depending on the agreements that you need to adhere to.
Thank you. The next one is, have you done any analysis of the output quality of AGT?
Yes, we have been running an analysis, so this is an ongoing thing. We want to do more analysis, and as we speak, we are working on this, and we are also working on increasing this quality. We did Back in the early days of memoQ, we like to talk about dog fooding the tool. So eat your own dog food, which means we personally translated a lot of remunerated work with memoQ. And in this case, we translated part of the new strings in memoQ's user documentation into German. And we did comparative studies also with a different machine translation provider. I cannot give you the exact figures, but this is really competitive, in some places better quality than the other state-of-the-art machine translation system that was also used as a basis of comparison in the project. So this is ongoing work, but this is also work that we want to do with you customers. So this is part of the reason why we decided to set up a waitlist. We want to really work with some of you individually very closely. We would like to gather experiences from the field, so to say. How does this work for you? Work together on methodically evaluating the results, talk about the results. So please come to us about this.
Thank you very much. The next one is games localization in mind here. What options for prop customization are available or planned? Different game characters may have a different personas, for example.
So right now, essentially the way to customize is the way to affect the output of AGTs through the resources that get fed into the generated translations. So it will adhere to the TMs, etc. It does not have any extra bells, whistles, or levers to say this character should speak in a particular register or something like that.
Thank you. The next one is that are there plans for enterprise customers to be able to use their own existing OpenAI accounts for AGT? And also let me ask that what API key you showed, was that OpenAI API key or memoQ AGT's API key?
That was memoQ AGT's API key, and I know you saw it. Rest assured that as soon as this webinar is over, that key will be revoked, so we don't even need to blur it out from the recording. The other question about using custom OpenAI model. Honestly, we don't have those plans. In fact, that's a pretty strong opposite of what we plan to do. The large language model, the specific large language model in the system is to a certain extent interchangeable. And we don't want to build a system which is a thin front end to Azure's or anybody else's OpenAI deployments. Anybody's welcome to do that. We are going to have ongoing work on the LLM part. So actually more fundamental work on the specific large language model that is used here, fine-tuning a large language model, finding models that have better support for translation / more languages. We are definitely very keen on hiding that from the end user experience. So that is the value add that we do in the background.
Thank you very much. The next one is, can you confirm that with the AGT model, there is no need to keep training the model? It continues to train itself as a segment gets saved after MTPE in the TMs.
So the first half, that's an absolute yes. This model is not getting trained. So the large language model in the background, it is what it is. That model does not change. There's no training happening there. That is also one of the reasons why none of your data can in any way affect anybody else's usage and output. With newly translated segments, I would not say that it trains itself because there is no training happening. The point is when you have new translations, reviewed translations that get saved in the TM, and the next time a sentence comes up for which this is a relevant match, the new translation will be included in the context and it will affect the output. So this is essentially the in-context learning will be affected, but the large language model itself does not get trained. I know this is at first a bit hard to wrap one's head around. It took us quite some while to grok it all.
Thank you. So the AGT results will not be shown up in the results window. At the beginning, I would really like to compare AGT's results with DeepL's suggestions, for example. Will there be a way to do that?
So we are working on that. There will be a long sequence of functionality coming with AGT. For this very first version, we went with something that was where we had like the straightest path to building something that we can put it out there and share it with you. The interactive translation results would have taken a bit more time, so we decided to not wait for those, but release it in this form. Those will be coming in an upcoming memoQ version, so that is definitely something we want to do. But you're right, at this stage, this only works through this Translate with AGT job.
Thank you. The next one is memoQ and some MT engines generally struggle with inline or regex tags. MT results tend to become non-sensical when those tags occur. If you try to have MT places the tags in the correct position with the segment. Does AGT provide a path toward handling tags within segment more accurately to reduce post-editing efforts?
This is a very good question. This is a research path that we are also working on. In this iteration, AGT only works with plain text, so kind of what many MT plugins do, most MT plugins did in the past. So it will just translate the untagged text and throw in the tags at the very end. But this is something we are working on, and this is actually also an interesting research area into other uses of a large language model. It might be possible to use one to put the tags in the right places, even if the translation comes from a different MT engine. So these are all avenues that we are exploring. Right now, it works without tags.
Thank you. The next one is, could you elaborate a bit more on the adaptive component?
The adaptive component is that probably the question, I assume the question came before I showed it live. I literally demonstrated this. So if that doesn't answer your question, then please throw in a note again and we'll come back to it.
Thank you. Can we expect support for Serbian or Hebrew languages in the future?
Eventually, yes. So eventually, we really want to expand this. As I said, at this stage, we basically looked at the volume of different language data in the training corpus of the model we are using, which is GPT 3.5, and just made an arbitrary cutoff point. Maybe that cutoff point, even with this model, can be made at a lower place, and we are definitely going to do more work into eventually fine-tuning and building dedicated models on our own. And the key, one of the key aspects of that is to broaden the range of languages where this works reliably.
Thank you. The next one is there a project setting to disallow the use of AGT on a project?
Currently, no.
And is it planned or?
That is a good question. Frankly, I have not thought about this. This is exactly the kind of feedback that we are looking to gather. So now I think in one form or another, this is definitely in this moment already an item on the roadmap.
Thank you. The next one is about quality estimation. Is memoQ AGT able to do its own quality estimation for its input?
It does not.
Thank you. How does AGT decide which segment to feed into the LLM?
It performs a lookup. So the same results that you see here on the right. And if there is the setting, let me bring up the dialog once again. So there is essentially an upper limit that you can say, I don't want to send more matches than X. So that will take, they will order the TM results exactly the same way as they are ordered in your translation results list, and will take the N best ones and send those. And with terminology, it will also take the N first ones and send those.
Thank you. What about documents only available in the target language, which you would import to a LiveDocs corpus? Does the model takes those references text as context for translating the source text, or does that approach not work at all?
It currently does not do that. So it currently only retrieves bilingual matches. So TUs from either a translation memory or a bilingual corpus document. It can be an alignment document as well. It does not rely on the monolingual documents at this point.
Great, thank you very much. The next one is, will memoQ register the AGT contribution per segment as it does with MT now?
I am not entirely sure what you mean if it registers. I don't. Can you clarify the question? I'm not sure what this refers to.
Thank you. Let me move to the next one now. Are there any plans to connect a tool like CotranslatorAI, or will similar functions be incorporated with memoQ?
I'm not familiar with this tool, so I don't know.
Thank you. Does AGT work equally well between languages that do not include English, like, for example, Swedish or Finnish?
It's a good question. We didn't test those combinations specifically yet. That is also something we want to look at. Honestly, as a hunch, I would imagine that the quality there would be less good than if one of the languages is higher on the list, so English or one of the other more well-resourced languages in AGT's corpus. That is just an intuitive guess. However, I do not have numbers to support that.
Thank you. And one last question. Is there any ranking for the things that we feed into AGT? For example, does turn-based has priority over TMs or LiveDocs?
Essentially, at this stage, AGT uses two bags of information. One is the fuzzy matches, and the other is terminology. So this number of how many items are taken from both are actually calculated separately for them. And the ordering of those is exactly the same that you set up in memoQ. So this is what I meant when I said it's great that this is part of the TMS. You have all the usual TMS functionality to rank that. You can use penalties. You can choose which resources to add to your project. That can be on the basis of metadata. It's the usual memoQ fare, I would say. And essentially, the list goes from higher match rates to lower.
Thank you. And I know we will go a bit over time, but I think that's an interesting question as well.
So let's do one more.
When AGT populates a segment, is there a way to see which TM, LiveDocs, or which source does the information came from?
No, that is not recorded. So that is sent along with the query, but then memoQ just gets back the translation. And even in the response we get from the LLM, there's no trace of, oh, it chose this word because there was that TM match or anything like that. In terms of that, these models are really black boxes, so we cannot know that.
Okay, thank you. And I promise this is the last one.
All right,
Are
perfect.
auto translation rule outputs taken into account?
Very good question. For the time being, it's not. We are looking at actually broadening the range of translation results or lookup results that AGT will use. Another interesting thing would be auto translation, definitely. Another interesting thing would be to look at these are the fragment and concordance matches. So if memoQ knows, hey, there is this particular sequence of words for which it's a good idea to do a concordance search, then maybe AGT will do that concordance search and also include matches which would be too low a score for a fuzzy match, but they just include an interesting phrase. So that expect a lot of interesting things to happen in this regard.
Okay, thank you very much. We have a lot of questions, but we ran out of time, unfortunately. But rest assured, we will answer all of them, and you will receive the Q&A sheet with the email that will also include the link to rewatch this webinar. Thank you, Gábor. Again, it was a really, really great webinar. I think we learned a lot about AGT. I just can say that everyone should go now to agt.memoq.com and join the waitlist.
Absolutely. And thank you everyone for joining and watching this webinar.
Thank you. Have a good rest of the day. Bye-bye.
Bye.